Okay, thank you everyone. Thank you to the ACM Student Chapter of Southern New Hampshire University, and thank you to Dr. Overmyer for the invitation to speak. We're very excited to talk to you. And tonight we're going to talk about interactions at scale, user experiences with many objects, and then we're going to start with covering some HCI principles of interaction designed for dealing with multiple and many objects, and then we'll cover a case study of how we apply these interactions, and at the end we'll do some Q&A. So we'll go ahead and start.
So to start things off, we'd like to just cover some basic interactions that we've run across over our time of doing software engineering. What sort of user experiences work best when we're dealing with lots of objects? So if we start from the very basics, and we just want to display a few items on a computer screen, we have a lot of flexibility. And I think everyone's seen this, and that if you only have a small number of items, you can put them all on the screen and the users can interact with them directly. You can click on them, you can drag them around, you can do whatever you'd like with the particular objects. So in this case here, we have a very simple page from Apple. It can fit everything that Apple needs on the same screen without having to scroll. It's a very simplistic piece. And it's given the flexibility to lay some things out horizontally, some things out vertically in the piece. Now, when we start to increase the number of things even more, then we normally think about putting something in a list. And a list is a very common interaction model that I think we all hit many times a day. So here, if we look at an example of looking at some shoes on an online store, we can see that we've represented each object, in this case a particular model of shoe, as a rectangular region on the screen, and we've placed them in a grid so that people can easily select from them at a regular spacings as opposed to just sort of randomly placing them on the screen. Now, we've obviously got so many items here, there's 1,600 items, that we can't fit them all on the screen. Without making them impossibly small to interact with. So obviously we can see from the very beginning that we expect to be able to scroll this list from this piece. Now obviously we can't just necessarily scroll forever. So the UI world then introduced the concept of pagination and doing things in pages. So a very common thing is that you have a certain number on a page. You have a finite scrolling, so you can scroll to the bottom, and you see a number of pages. In this case here, we've got 17 pages of different shoes. But in actual practice, when you look at the way that people use a computer interface, anything that's not really on the first page doesn't really get used. And by the time you get to like page 5, so close to 0 people go past it. So as a mechanism for being able to show lots of items on the screen, the list doesn't really scale very well. Now, when the world has gone to mobile and you're now starting to use touchscreen to interact with things, the concept of infinite scrolling came up. And here, instead of having to page and have a finite scrolling model, we've just allowed ourselves to keep scrolling and scrolling and scrolling with the assumption that after a while we will get to the bottom and the user just gets tired, and at that point it doesn't really matter. And a good example of this I think we've all ran into is the Twitter user interface, where you have this stream of items that are being placed in front of you, and you can just keep scrolling down until you finally give up watching cats or whatever the other items that you're looking for is, and go on to the next thing in your day. So infinite scrolling it's different than paging. It may or may not be more effective at getting things that are not on the first screen in front of the user, but it's still a problem if you have to deal with a huge number of items that you can't just easily scroll through from that perspective. So then the next thing that we sort of go to is we say, well, maybe we can reduce the number of items that we have to do, so we can cluster things together. And if we think of clustering from a very classical sense, you think of points on a map. So here we have a map of the North America, and we have so many points that we've displayed on the screen that we really can't interact with any of them. They're all overlapping on top of each other. You're losing points underneath each other, and it's just a mess from piece. Not to mention, if you're trying to implement this, it has certain performance issues from that perspective. So we can apply a simple clustering algorithm to this and summarize these results so that they're in a much more easy to navigate mode. So here we ran a very simple clustering, pulled together the clusters, and from the interaction point of view, we then basically have displayed a summary in each cluster as to how many items we pulled into that cluster. And we've used a pie chart here, or a modified pie chart, to be able to display the values of the average value of those items that we do. Now, obviously from an interaction model, you can no longer just select an individual point on the map and interact with it, but you'll have to do multiple interactions, select a cluster, and then obviously interact with the details underneath that. So a little bit of extra things, but you've got a much more usable map interface in this case here. Now, clustering also appears in other places in the user interfaces that are not quite so obvious. So if we take, for example, this clothing store, in the clothing store here we have a whole selection of shirts, all the same pattern that we have, and it's laid out in a grid according to the particular color that's on the shirt. Now this of course means that the one model of shirt, the one pattern, has taken up the entire user interface here, all 6 of them. Interestingly enough, on this same clothing site, when you look at the female clothing, they've taken the clustering approach, where instead of saying, oh, we're going to display 5 items on the screen as being the same dress in different colors, they've actually clustered all 5 colors into a single item onto the screen. And yes, you do have to have an extra level of interaction to get to a particular color, but you can show so much more on the user interface by just being able to pull that together. If we still want to go for even more items in a list, then the common approach is just to do a keyword search. And I think we've all seen that. You end up with some website, you enter in a keyword, and it gives you back lots of results. Now, obviously, the results that it gives you back are less than if you had it list all the possible results or all the possible pages on this website, but it's still going to be a very unmanageable list of everything, which is not very useful to anyone. So to try and make it manageable, we want to then apply some other techniques to this list of results. And the first one that we apply is really to help the user search more precisely. So instead of just searching for a simple text string, is there some way that we can prompt the end user to allow them to create a more exact search? And the most common of this is the faceted search. And by faceted search is where we take a list of items, so in this case unicycles that we're searching for, and the system is smart enough that it goes and looks for common attributes on a particular unicycle and shows them as criteria that the user can select. So effectively adding an AND statement into the expression, but doing it in a very simplistic way that goes forward. And the sidebar is a very common mechanism for seeing this in user interface today.
I think it's also important to note that the facets sort of serve as prompts for the user to help the user refine their search or craft a better search.
Correct. Now, the same concept of facets appear in different places. So if we look here, this is a bug tracking application that I think a lot of people have used. And in that case, the search displays the facets in a horizontal section. But they're the same way. They're a combo box where you pull down and you select a particular item. Now, obviously for us computer scientists, all this extra user interaction, combo boxes and everything can be a bit of a pain, and we'd much rather just write out a query language where you can just write the expression and off you go. Unfortunately, in the real world, not everyone is a computer scientist, and creating expressions like this is not something that most people are familiar with. So if you go out and you look today at the number of different search interfaces that you find, where you enter in the word and or, and it actually creates an expression out of that, it's very, very small. It used to be a decade or two earlier, it would be quite common that you could put and in a search criteria, and it would actually be an and. Whereas today, you just add multiple terms in there, and they can be ands, they can be ors, they can be fuzzy matches, like what you would end up with in Google. So not everyone loves query languages, unfortunately, today. Haven't proven to be overly successful. Now, once we can try and search things, okay, and we've managed to get a huge collection of items, we've done a keyword search to get the first sort of piece, we then done some faceted search or added some extra criteria to shrink the results even more. Sometimes you still just have too many things to fit on the screen at once. And so from a user interaction point of view, we have to try and organize the results. Now, obviously, the one that most people think is you just sort them. And sorting has its advantages and disadvantages, but there are some other fancier pieces that you don't always think about that come up in the world. And the first one I think that we're starting to see more and more of in user interfaces is a concept called progressive disclosure. So here, if we search at Google for a combination of unicycles, okay, obviously there are many different types of hits. I can have a hit of a web page that describes unicycles. I can have images that describe unicycles. I can have places that describe unicycles. And so in each of these areas here, what Google has done is basically grouped together a whole pile of results by the attributes of them. In this case, the kind. Is it a website? Is it an image? Is it a place? And just show the user a summary of all of those things. So it's sort of a clustering piece, but it doesn't disclose all of the results. It sort of makes the user have to dig into the results a little bit. And in that way, if a user is just searching for unicycles and they want an image, yes, they'll have to have an extra click. But if they're looking for a web page, they can now fit a lot more links onto the screen at the same time. So progressive disclosure is becoming more and more common. Now, from a sorting perspective, we can obviously very easily sort by criteria. So if we're going to buy something, we can sort by price. If we're going to find a place, we can sort by distance. But what we've discovered in the reasoning world is that people like sort of patterns. And so we can actually start from a user interface point by sort by relevance. And I think this is really sort of clear in this example from Google Maps, where I'm searching for cafes. And Google Maps has this history of all of the different coffee cafes that I've visited. And therefore, it can sort of look and say, oh, this cafe might not be the closest, but it's very similar to ones that I've been to in the past. And therefore, you end up with this percent match score that Google is doing, which is rating it on how much. And so instead of searching just by distance or whether it's open or not, it can actually show things that it thinks that I'm most interested in at the top of the list. And as machine learning becomes better and better, we're starting to see more and more of this sort of stuff appear. Now, of course, there is the classic one where this comes out, and this is, of course, a case on Amazon. You search for one thing on Amazon once, and it follows you around for the next 3 years, always prompting you for the same thing. But that's, once again, that's the system saying, okay, I've got a huge list of items which I could show you, and obviously showing you just a big long list is really not very useful. So Amazon here has tried to pick out the most relevant item, which it thinks is the one that you last viewed, and goes and shows it straight in front of the end user. So I think we now have a toolkit of different interactions for being able to deal with objects at a high scale where we can't just easily fit them on the screen. Now, the at scale could be just as simple as, a number that can't fit on the screen, or it could be thousands or even hundreds of thousands or millions or tens of millions of items. And once you get to a certain scale, at that point, the user interfaces have to start to change, and the engineering techniques behind it have to change. If I have 10 items, I can easily load them from a database, sort them, display them to the user. But if I'm doing something like showing a paginated list and I have 100,000 items, I load them from the database, I sort them, I take the first 20, show it on the screen, and then I have to toss away that whole sorted list. An awful lot of effort and performance work. So therefore, sometimes you have to start thinking about a user interface which may not just show the first page of 17, but might actually just give the user a prompt and say, found 5,000 items, please refine your search, or something similar to at that point.
So we're going to actually show you a case study of some of the work that we've been doing. This is an app called Local Haze. It's available for free for iPhone, available on the App Store. And by working on this app, we've been able to put into practice some of these interaction techniques. So what Local Haze does is it crowdsources air quality sensor readings all over the world, and then it rates those sensor readings for accuracy. It uses heuristics to do that based on recency and other attributes. And when we started, we only had about 500 sensors globally. And now, this is a screenshot I just took from the app today. We're about almost 18,000 devices all over the world. And so these are all kinds of devices, either home kits that people put on their porches, the Luftdaten are DIY air quality sensors that people build, put on their porches, and then AirNow and Department of State are government-sponsored air quality sensors. What we started with is we said, okay, we've got all these sensors, and we need to show them to the user and allow the user to interact with them. Let's start with an infinite scrolling list. So you can see here, this is what we call the sensor screen, and it is just a list of all of the sensors that are available in that region, and the user just scrolls through, and eventually this was fine at the beginning when we only had 500 sensors, but eventually when we had 2,000 sensors, this wasn't going to work. So we needed to help deal with the management of a large list size, and so we decided to add a feature called filtering, which it turns out is exactly that. It now allows the user to enter a keyword, a simple keyword, so not the complex queries or conjoined queries that Craig was showing earlier, but just simple keyword. And then this filters the list. So you can see now the sensors are being filtered, in this case by the keyword London. So the sensor locations are coming into play. And you can see the wide variety of the kind of sensor data. So you have sensors where the air quality is really good, and you have also sensors that are showing where the air quality is very poor. And also that little badge on the lower right-hand side is that confidence rating that we talked about earlier. So in some cases, we have high confidence that the sensor rating is accurate, and in others, we have very low confidence. So the air quality measurement is actually showing good quality, but we have low confidence. So that means you should perhaps be suspect of that reading. So after filtering, we said, well, we're still getting requests. Users were writing to us and saying, I really want to keep my sensor that's on my porch at the top of my list. I don't want to have to scroll through lots and lots of sensors in order to see my sensor. So we added filtering. And so what we did was we added relevance. And so relevance means you can actually say, this is my favorite sensor. I want to kind of pin it so that it always shows up at the top of the screen. So on the left, you can see the user is setting a favorite, and on the right it shows that that sensor is now pinned to the top of the list, so they don't have to scroll for it. Below in the sensors list, everything is scrollable. So that turned out to be a really useful feature. People really liked that and wrote and told us about that. But it wasn't a feature that we had come up with. It was something that our users told us that they wanted. And then we added a map view because we felt that users needed to better understand the contents of the list that they were viewing of these sensors. And so as Craig was showing earlier, we started with a non-clustered map. So on the left, you can see there's the map on the device. This is North America. But at certain scale, it just becomes unusable. The interaction is poor. The performance was also very challenging. And on a mobile experience, you really need to be performant. Users expect that maps are going to rescale quickly and that they're going to be able to zoom in and pan, and that was causing a challenge for us. And so we had to rewrite some of our algorithms and redo software. So on the right-hand side, you see the current rendering, which is a clustered view. It's very, very performant. It's very fast. And users can then tap on a cluster and then drill down and look at the sensors in that region. And they're all color-coded, so you can sort of have a sense of what the air quality is in a region. And, you know, and sometimes when there are environmental issues, fires, etc., you can see that the maps really reflect those changes, those dynamic changes in the air quality. And so we learned a lot of lessons, I think, in developing this, especially the things that we think are worth noting, which is we really think and recommend that you use the best interaction models based on what your users need. So users told us we need to be able to sort of pin our favorite sensors to the top of the list. We said, okay, we built that, we deployed it, and we really needed to listen to users to find out, you know, we made our best design choices, but it was really after deployment in the field that we were able to hear from users what they wanted, and we ended up having to use multiple interaction models. So we recommend, you know, don't be afraid of using multiple interaction models if that's what the user experience demands, if that's what users need, and that they're telling you what they want, especially when you get to scale. So, you know, in a lot of our corporate work, we're dealing with managing entities about hundreds of thousands, million, or maybe multiple millions of devices, etc. And so we deal with scale frequently. But the challenge in local Haze was that we were designing for a consumer user that would be using an iPhone, but who is also a sort of a citizen scientist and an air quality enthusiast. So the user modeling was a bit, I would say, complicated. And this demanded multiple interaction models for what we needed to do. So you can see on the left, there's our map clustering. It's now, we've got it to the point where it performs well and it solves the challenges that users are trying to accomplish, which is trying to find the air quality in their region and then be able to drill down into details. In the middle, we have filtering. That's worked really well, also performs very, very well. And on the right, you can see the favorite to be able to pin and sort of have a relevant sensor be associated at the top of the list. So that's our presentation. We wanted to open it up and see if anybody has any questions